Okay, really quickly, just some verbiage. Let's get it out of the way. When I refer to an inequality as a compound inequality, I'm simply meaning that it's an inequality that has more than one inequality symbol in it. So really simple example might be something like -5 is less than or equal to some mystery value of x, which has to also be less than, let's say, 10. Okay, or another example would be 2/3 is less than some mystery value of x, which is then less than, I don't know, 7/11, 7/11. Okay, where the idea here is the value of x can be any number on this left side, any number in between -5 and 10, and it is okay if it's equal to -5, but not okay to equal 10. So it could be like 9.99999, but not 10. And it's okay if it's -5.0, -5, or -4.9999999, but beyond. Anyway, I think you get the point of that. Likewise here, oh man, I just made this up. Let me do a little bit of arithmetic. I want to make sure that 7/11 is bigger than 2/3. Otherwise, I may have just done something that's nonsense. That's silly. But I'm going to leave it in whether I'm right or wrong. Oh, I was wrong. 7/11 is smaller than 2/3. 2/3 is 0.6 repeating, and 7/11 is 0.636363, just less. So, okay, math teacher goof. Let's make it 17/11. There we go. Now it's definitely bigger. Okay. So 2/3, x could be any value in between 2/3 and 17/11. This time, it cannot include either 2/3 or 17/11 because those are strict less thans. And so the interval notation that we might use to represent those two inequalities would be on the left, everything from -5 with a square bracket up to 10 with a parenthesis, or on the right, parenthesis 2/3, comma, up to 17/11, close parenthesis. Okay? So these are actually a little more intuitively true than, the ones that continue on unbounded to positive infinity or negative infinity. There's very little question about whether we should be using parentheses or square brackets. So what we want to focus on here on this example, though, is how do we solve an inequality when the variable x isn't already isolated like it is here and here. So hold up, let's head to the next slide. For this inequality, to solve it, again, I want to isolate x, and I'm going to use the same strategies I use in just regular equation solving. I'm going to focus on where x is located. It's here in the middle part. And so if I ignore the right and ignore the left and just focus on, this is 7x plus 4, what would I want to do first to begin isolating the x? Well, I'd isolate the x term, 7x, by subtracting the 4 off. So our cardinal rule of algebra has been you can always do whatever you want to one side of the equation so long as you do the same exact thing to the other side. Problem here is we don't just have two sides. We've got the left side where the 11 is. We've got the middle where the 7x plus 4 is. And we've got the right side where the 25 is. Cool thing here is we can just extend that cardinal rule. And if I want to subtract a 4 off from the middle, then all I have to do is also subtract off 4 from the left and 4 from the right. So again, the idea just gets extended. Do whatever you want, wherever you want, so long as you do the same algebraic action to all three parts. Okay, so according to math, no, I didn't want to do that. Y'all can't see what I'm doing over here. 11 minus 4 is 7. Sorry, I did not get a good night's sleep and I'm pretty sleepy. So I'm having a lot of dumb moments. Subtracting 4 is not me dividing by a negative number, so I don't need to flip. It stays less than or equal to. In the middle, 4 minus 4 canceled out, leaving 7x. Bring down that other less than, and 25 minus 4 is 21. Okay, next step, intuitively, focus on the x in the middle. What would I need to do to get rid of multiplying by 7? I would divide by 7. And once again, because I'm dividing all 3 parts by a positive number, there is no need for me to flip a single inequality symbol around. Less than or equal to stays less than or equal to. Less than over here stays less than. And otherwise, I'm just going to do the arithmetic. 7 divided by 7 is uno. Likewise, in the middle, that 7 divided by that 7 is 1x, which is just x. And 21 divided by 7 is 3. So my solution set for the original inequality there is x may be any value in between 1 and 3. It's okay if it equals 1. 1 is also a solution, but it may not equal 3. It can equal 2.9997, but not 3. So final answer in interval notation. I'm just going to jot it over here to the right. Square bracket 1, comma, up to 3, close parentheses, and that's my ball game. Okay, I'm going to do one more example for you guys that's got a compound inequality and fractions and just about every other trick in the book, just because I know you guys enjoy watching those. So see ya on the next video.